So hi and welcome to part 3. So this time around we finally got a set of drawings for you. They're preliminary, and in this episode I work on the bottom half facing it and correcting a major problem I made. I made a huge assumption and was wrong, so let's get to it. So real quick, here's the setup on this guy. First I'm going to machine these flats, these 3 flats, make them all match, then flip it 180. Set this on the mill surface, on the bed surface, and mill these guys flat to match, and we should be good. It may not be absolutely perfect, but it doesn't have to be. So it should be really close. So this first cut only got this edge just lightly. That's because it's sloping heavily towards the back, maybe a 1/16 of an inch. Terrible. You know, the plasma cutter, the flame starts to, or the plasma starts to spread. So when you're doing thick materials, you can end up with an angle really commonly. And this one is no different. 65 thousandths didn't get it all, but it got most of it. And that'll be good enough to have it lie flat. So we just milled this guy and this guy flat and matching. We've already got this guy flat as a reference point. So now these guys should be parallel also with these, which are even more important. And we'll move on to the next step. So to my dismay, I made an assumption that was a really bad assumption. And that assumption was that the center of this space was the center of the lathe, but it turns out that that's not the case. I did, verify it by eyeballing it, but I did not do any rigorous testing, which was completely my bad. So I'm off by 1/2 inch. The center of this is 1/2 inch off of the center of this. So this guy needs to come this way. I'm not very happy about it, but I'm going to have to make another slot like this over 1/2 inch and see how much material I can catch. Very disappointing. My bad. I mean, so far the machining's all been right, just my initial measurements were off. And that's what you get when you're not rigorous and you just eyeball something. And I figured, why wouldn't they center it on that gap? But they didn't. Alright, I'll be back. I'm currently in the process of filling in this gap here, the angled section that mates on the lathe on this part of the ways right here, because of my screw up, and this needs to be over 1/2 inch this way, so I'm going to fill it in and then recut it out. It's going to take me a while doing this with TIG. Probably could do stick, fills in faster. I've just never done stick before, so I'm going to stick with the TIG, and so here it is built up, and then we need to machine it back down again and then put a slot over about 1/2 inch. That's why I took measurements before I filled this in of exactly what that is, because it needs to go over almost exactly 1/2 inch. So we will do that. And because I was so far off, I've also welded an extra piece of metal on the end here so that this part can lie on the flat part of the ways. It's not strictly necessary, but I wanted to just make sure I'd still be able to hit my mark. The center part, which is now really narrow, that actually doesn't matter at all, because that was just sort of to loosely center it, but the slot I'm going to put in here is going to be the final decider of where this sits, because that 90-degree slot will fit on the slot on the ways right here, and that'll keep its position very tight. So now I just have to machine all this down, all the extra material off on the sides and the top, and we should be good to go to continue to put the new 45 or 90-degree slot in here. And all right, well, let's just get to it. So what I'm doing is I am now going to mill out the V slot after carefully double and triple checking its location. The center of it is referenced off this edge, which I have made square. And so I'm going to do it in steps. I'm going to drill the small, and I probably should go the other way around. It seems like it'd be more logical, but I've already got the milling cutter in here. This is a roughing mill, end mill. So I'm just going to go down the 4/10 of an inch with this guy, then go down with a 1/4 inch, and then with a 1/2 inch, and remove most of the material before I bring the V cutter in there. I'll bring you back. So you can see here that before I do the actual slot, I've milled out a lot of the material already with big end mills. so that the somewhat delicate chamfer cutter doesn't have to work so hard. One of the other things that you might be interested in is how I calculate the depth to go for each of the size, the 1/2 inch and the 1/4 inch. And what I did was I used my CAD program, Corel CAD, just to lay out a 45 right triangle, and then just placed a 1/2 inch wide line across where it intersected with the triangle and calculated that depth using the program. Same with the 1/4 inch. If not, you just have to use some trig. Also note that this cutter is not wide enough to do the final width, so I'm actually going to have to go, when I go the depth I want, then I'm going to have to come back and I'm going to have to go left or right a few thousandths, almost 100 thousandths each direction to get the final depth right. I mean final width right. So give that a shot. Taking a light pass just to test it out. Right now it's only engaging on the very, very edges. Once more material starts to engage, so right now it's just engaging here and here. So we'll try 25 thousandths. That may be too much, I'm not sure. I just realized I got the order wrong for this. I'm going to be right back. I also almost made things really difficult on myself. So I have this smaller cutter, which is what I was going to start with, but it turns out I have this larger cutter, and the final width on the top of this needs to be 0.907, which I'm going to shoot for like 0.905 just so I can come back if I get it a little off. If I start with the big one and get this width 0.907, then I can just take the little one right down the center and just clean up what's missing. So that's what I'm going to do. I'm going to start with the big one and then get the little one just to clean up the bottom part that was barely getting touched, because this one's kind of delicate. So that's what we're going to do. So I'm doing 25 thousandths passes, and what I'm going to do is I'm just going to keep going until this width here is 0.905. We're quite a ways away, so finish isn't terrible. So I'm going to come get a quick measurement and be right back. So up to this point I was rough measuring with my calipers the distance from here to here, but it's very, very hard to get anything even halfway precise when you're measuring between here and here. So what I am going to do is I'm going to take a 1/2 inch gauge pin and I'm going to sit it down in the V groove and then measure the height above the horizontal, which should be 0.151. Now, rather than actually calculate this out with the math, I just again used my CAD program, laid out my V in dimension, put in a 1/2 inch pin, and then measured using the CAD program. That is the lazy way, but it saved me some time. So this is a 1/2 inch gauge pin, and the final width I'm looking for is 0.905. So we're going to do that. So instead of using the calipers to measure from here to here, I have put my 1/2 inch pin in the slot, used my uni mic, and put the carbide surface, the ground carbide surface, flat on my milled surface, brought the anvil down slowly until it touched with the friction thimble, and got my measurement, and we are there. So if looking at the uni mic was a little confusing, here's the uni mic put together. I had unscrewed the pressure plate that holds the ground measuring pieces. You have, let me get my hand out of the way here, there's a ground pin and a ground flat that you can use. This is an incredibly versatile micrometer, so I highly recommend getting one. I took this end part off completely, so I've got a ground flat surface and use that to measure depth. So there you go, mine's a Fowler. Very nice, highly recommended. So now that the fix is finally complete, I had to tack on a piece of material on the end here so that it would have some lip to ride on the flat surface, recut the V groove, the 45 inch V groove. It basically got moved over a half an inch. The center was over half an inch. Cut some more of the center material out. So not happy that I made the mistake, but was able to salvage it. This is more or less centered now. It's off by you know, 20 or 30 thousandths, which isn't a big deal because these adjustable pieces will easily make up for that. So that leaves me with drilling and tapping the ends here, and drill and tap this side once it's together, and then make the pieces to go in. So we're going to start on the next. So it took some serious effort to get this guy hanging off the side of the mill so that I could drill it. I've got two clamps, two can twist clamps, and a rotating point. This is kind of essential, otherwise you're going to have a heck of a time holding it. So this is just a piece of aluminum that's going to this T-slot, which interestingly enough is not the same size T-slots as the rest of the mill. So I had to use my 3/8 T-slot clamping kit with a special sliding bit because the 3/8 ones were too thick to fit in here. So anyways, we got it, and we're going to start drilling next. And I probably don't need to show you that since you've already seen that, the drilling and tapping. I just wanted to show you the setup because it was something. Anyways, I'll be back. So after correcting my big mistake here and moving this slot over half an inch, I finally finished threading and tapping and drilling both of these guys, which took an amazing amount of time, about 3 hours, 2.5, 3 hours each. We're ready to move on to the next step. So I've got to drill a 3/4 inch clearance hole here and a countersunk 3/4 inch hole up here for the clamp. That's this guy. It'll clamp to the bed, and I'd like it to be recessed, so it's going to be like that. And there's these two guys. Now, they provide a little bit of an issue here because the plasma cut, as you can see, is not great, especially if you look in here. A lot of flaring on the flame. Must have been cut from the other side going this direction. So a lot of flaring. The flats meet where I put here, but I'm going to have to, because I milled the flats on this guy and this guy based on my bottom and my top surfaces here. So they should be parallel, but you notice the inside doesn't meet, and I guess I'm just going to have to blend that with a sander after I'm done with this. In the meantime, I'm going to fixture these up on the mill, and I'm going to grind these guys, or not machine these guys flat and even with each other so that I can have a reference point to come in to drill my holes. Otherwise, I have no idea how to line these holes up. I mean, I could try and build this whole thing vertically on the mill, but I think that would be really challenging to hold it in place and get it lined up and everything, to drill all the way through so I can tap the bottom. I think easier if I line these up based on having these flats be equal. So I'm going to set these guys up on the mill and line them up as closely as I can, then mill the flats on this side, and then measure in, figure out what distance in relative to what my drawing says I should do the 1/2 inch bolts. After I do that, I'll try and drill this guy, and then all I have left is the 3 holes for the threaded screw, the lockdown screw for the shafts that come out the middle. But I'm going to hold off on those till I'm done. I've sort of got some, I've been thinking about it a bit, and I'm not really sure exactly what I want to do. So I'm going to make sure I've got, you know, my head clear before I drill holes, because this was a costly mistake that took quite a few hours to remedy, so I don't want to reproduce that. So let's move on to the next step. So step 1 to this process is to use these parallels and to get these guys parallel to my x-axis here. And it doesn't have to be super critical, but I want it to be close. So right now it should be pretty darn close. Then I had to build these posts up, got them sitting on some large parallels, and the next step will be to take these 2 parallels out and mate the other half of this up, line it up to where they're close, and then come back and do my milling. All right, I'll bring you back in a bit. So I measured the distance on both sides from here to here, but because the inside of this is not very even, what I'm going to do is I'm going to mill a little bit of a flat here, so I've got a good measurement point straight down the middle. So I'm just going to mill the little flat on the inside of both sides, same there, same here, so I can measure this distance as I'm cutting this flat and get some sort of repeatability. Because it's so uneven, it's really hard to do. So it's not important that, you know, from top to bottom that they be equal exactly. What's important is that I can line up these screw holes, and if I keep making the measurements, you know, I guess it's not really a big deal, but I'd like to do it anyway. So I'm just going to mill a little flat. It'll look a little funny, but we'll try and make it not too terrible. So I didn't want you to have to listen to the milling on this because there's a lot of squealing, because this is a relatively small milling cutter. I need a longer length of cut cutter that I don't have. So I'm using this one, but it's got a lot of stick out now. So there's a bit of squealing. So I didn't want you to have to listen to that. Anyways, now I've got a flat on each side right here. If you pop on in. So each of these pieces is flat relative to each other right here. And now I can do a measurement from the center out and see if I can make them equal. Alright, so we've got the flats here all the way top to bottom using a roughing mill, end mill. We've got the flat over here as well. So now we come and if I can get out of the camera, prevent the camera from affecting it, and go across both plates. 3.395. So now we'll try and make the other side match. Roughly. It doesn't have to be exact. The important thing will be the distance from the flat I've created here to the center of this hole, so that both pieces, the hole can line up the same. Front and back should be parallel and the same width. You don't feel much of, if any, of a bump here, so we should be good to go there. So anyways, I will just continue right along, bring you back. So this side here was off by more than 1/4 of an inch with this huge flame cut. I think they initially penetrated here, which they should have done off the piece, but they didn't when they plasma cut it. So there is a huge indentation here. I'm not going to cut off a 1/4 inch material to make that match. I just got enough of a flat spot here that I can identify this edge. So I'm going to deburr this. Then we're going to change the setup again so that I can drill these parts and tap the bottom part. Alright, so this is the top. So this, both sides of this get drilled through 1/2 inch. And the other side will be drilled and tapped. As you can see, every time it's another setup, all the way from the top of the travel to the bottom of the travel, practically bottom of the travel all the way, top of the travel most of the way of the knee on this mill in order to reach these parts. Pretty freaking amazing. Anyways, I will do the drilling next. So you can see this hole's not even a little bit round. Right there. Because I totally blew it. I thought the clamping I had on this was adequate, because I figured I'm not pushing that hard, I'm drilling, but the torque arm is really long. It's you know, about that long from the center point. So it actually rotated, because I didn't really reef on these, but I've added another clamp, and we're going to start again. Boy, I blew it. So I went and refound my side again just to be sure. Came back in, look at that, that's terrible. Anyways, we're going to, that's better, less glare. We're going to go small and build up so that we make sure we follow the center. That's terrible. Shame on me. Had no idea those clamps weren't going to be tight enough. Or enough on their own, because I didn't think there was that much force. So wrong. So you can see a little bit where I screwed up here. It's not too terrible. So what I did was, let's bring you back here and show you what clamp I added. I added a clamp on the opposite side because it pushed down hard over here and lifted up on this side just a little bit, pivoting around the base here. So I have clamped it up high to give it a torque arm close to the other side that would prevent it from moving. So now I'm going to move this to the other side so that when I drill this side, it will be equally supported. So I've decided the big cant twists, especially up high, are doing a pretty good job. So I'm going to try and use them, and I'm going to be careful not to push too hard. We'll see how that works. This piece also has a much flatter base, less of a rotating point, so we're going to give it a shot. This side has to be tapped. Alright, so this is the next setup. Everything requires a new setup. The cant twists are working fine. When I was way out here on the edge, I had to add a second one on the opposite side just to keep it from moving. It did want to move. For this one, I'm going straight down the center, supported by these two 1, 2, 3 blocks. And so you'll see here I've got, let's see if I can get in here. So you can see I've got this, focus. Alright, so you see I've got this lined up on a center mark that I got by setting the center on the steady rest on the lathe itself, measuring across both sides and coming up and marking it. Again, doesn't have to be super critical, just has to be within 1/8. This would be within a couple thousandths, so that'll be good. Alright, so we're going to drill for 3/4 body and then 1 1/8 for the head. Crazy, these holes take forever, these big ones. Alright, I'll be back. So here I am stepping through drilling. I've got the 3/4 inch drill for the final all the way through pass for the clearance. And I'm thinking, man, when I first wanted to drill this, the center drill started walking downhill here. And then I'm thinking, wow, shouldn't it be at the flat at the bottom? And so I had to actually take a milling cutter, mill a flat, and then put my center drill down and drill through. And I'm looking and I'm going, whoa, this is 1/2 inch off. And yeah, it dawned on me. Remember, the center of the base that mounts all of this stuff is 1/2 inch off center, the actual center of the lathe. So even though this hole is 1/2 inch off center from here, the gap between the bed and the ways is off by 1/2 inch. So it had me going. But in any case, we're going to finish the 3/4 inch drill, and then we're going to do the 1 1/8, and we should be done with this. Well, as always with this project, because of the scale of the size of the pieces I'm working on, I keep running into snags. So I had the larger drill bit where I could countersink this outer part. I even actually have a countersink on order, but it's not going to be here for a week. So what I've decided to do is, because the drill bit and the adapter for the MT4 won't fit underneath the quill, I'm going to bore it out instead. So I'm going to do that, and I'll be back when I'm done. Last pass. One of the things I've learned is that you have to lock your ways, especially with an interrupted cut, because it started to deflect my bed a little bit, a couple 1/1000ths. So locked it all down, much cleaner sidewalls. Last pass. Alright, so here's where we are today. Here's this guy fitting. Here's the plate. And the top. And here's my flats for alignment. Not that I need them. I also need to get the right size Allen bolts. I don't have any long ones, so I need to order some. You just make these guys right here, the bearing posts, and we'll be done. So that concludes this one, so I hope to see you next time.